Okay, boys and girls, welcome to our first video lesson in Chapter 2, our lesson on quadratic functions. Here we go. Okay, let's just do a quick function review. Our first type of function, of course, are our linear functions. The equation looks like this: y equals mx plus b. The graph looks like something like that, right? And we know that. All right, a direct variation function is a linear function that passes through the origin. So there is a direct variation function, and a constant function, of course, is a horizontal line. Its equation is y equals b, and it might be down here at about -3. And the identity function is a special function where y equals x, and it, of course, is a direct variation function that passes through the origin and has a slope of 1. We also know about absolute value functions. Its equation is y equals a times the absolute value x minus h plus k. It, of course, when we graph it, makes a v with its vertex right there being h comma k. The greatest integer function is y equals greatest integer. I should put the a out here. X minus h plus k as well, and it, of course, makes a step function, which you guys hopefully remember. And quadratic functions, of course, are the parabolas. Y equals ax squared plus bx plus c, and it, of course, when we graph it, makes a parabola. Okay, quadratic functions come in really a lot of forms, but the one that you know the most already is the general form. This is the equation. This is the function right here. Y equals ax squared plus bx plus c. Our standard form, or I like to call it the vertex form or the HK form, looks like this. Okay, I like this form more where the k is on the right side as opposed to being on the left side, but I like the one where the k is on the right. Our vertex, of course, is at HK. And the roots form is when we factor the quadratic equation, we have our roots at x1 and x2. And of course, you know these words. The quadratic term, the x squared term, is the a term. The linear term, or the x term, is the b term, and the constant term, which is actually x to the 0, or the non-x term, is the third term, or the c term. When I graph a quadratic equation, I get a parabola. Its vertex is right here where the parabola turns around. That's my little my smiley face. The axis of symmetry is this purple line. It chops the parabola in half, two equal mirror images, and it passes through the vertex. And of course, these points right here, this one right here, and this one right here, these are my roots, or my solutions, where it passes through the x-axis. Of course, is called, these are my zeros, or my solutions or answers to the equation. If I want to find the vertex of my parabola, I have three options. The one you probably remember the most is when my equation is in general form. I take negative b over 2a, and that's going to equal my x, and then I take that value and I plug it into my function to find the y. My other option, of course, is to convert it into HK form by completing the square. We can try some of these in class. Or, of course, you can use your graphing utility and find the min or the max on the parabola, which we know how to do as well. Okay, I want you guys to solve this equation using the quadratic formula. Go ahead. So we have x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Pretty cool now. If I add these two roots, in other words, I'm going to take negative b plus the radical all over 2a plus negative b minus the radical all over 2a. What happens now is my radicals will cancel, and I have negative b plus the radical plus negative b minus the radical, so I have negative 2b over 2a, which of course equals negative b over a. So if I add the roots of a quadratic equation, I get negative b over a. Now let's multiply these roots. So I have negative b plus the radical all over 2a times negative b minus the radical all over 2a. Notice that I have conjugates up top. So I have negative b times negative b, which is b squared, minus the radical times itself. Well, what's inside the radical? It's b squared minus 4ac all over 2a times 2a, which is 4a squared. So I'm going to do some simping right now. It looks like I'm going to get b squared minus b squared, which is nothing, minus minus, which is positive 4ac, all over 4a squared, which is 4a. Notice now I can cancel my 4's, cancel my a's, and I'm left with c over a, which is the product of the roots of a quadratic equation. So we just said it. The sum of the roots of a quadratic equation, when I add the two roots, I get negative b over a. And if I multiply the roots of my quadratic equation, I get c over a. So if I'm given two roots of a quadratic equation, how can I solve, or how can I figure out what the equation is? We have two options. First of all, we can use our roots form. So I now know that if I have roots of 7, I have a factor of x minus 7, and I have a root of negative 4, which means I have a factor of x plus 4. So if I FOIL that out, I'm going to get x squared minus 7x plus 4x minus 28. So I have a quadratic function of x squared minus 3x minus 28. My other option is to use my sums and my products. So if I add these two roots, 7 plus negative 4, I get positive 3 over 1, which of course is equal to negative b over a. If I multiply these two roots, I get negative 28 over 1, which is equal to c over a. So now I can see that my a is equal to 1, so I have 1x squared. My b is equal to neg 3, so I have minus 3x, and my c is equal to negative 28. So my equation, again, is x squared minus 3x minus 28, which is what we got before. If I have these two roots and I want to figure out what they are, yes, I could FOIL these out. So I would have x times. So if I have a root of 2 plus root 3, I'm going to have a factor of x minus, in parentheses, 2 plus root 3. I also now going to have a root of 2 minus root 3, which means I'm going to have a factor of x minus 2 minus root 3. Well, we now have a triple FOIL, not very pleasant. So let's instead use our sums and our products. If I add 2 plus root 3 plus 2 minus root 3, I can see that my root 3's will cancel, and I have a sum of 4. So 4 over 1 is equal to negative b over a. And if I multiply these two roots, I can see once again I'm going to have conjugates, so I'm just going to multiply. 2 times 2 is 4. Minus root 3 times root 3 is 3 equals 1. So 1 over 1 is equal to c over a. So my quadratic equation is going to be 1, a is 1, so 1x squared. B is neg 4 minus 4x. C is 1. There's the equation with roots of 2 plus root 3 and 2 minus root 3. 3 and 0.4. Again, I'm going to use my sums and my products. So I'm going to add, and I'm going to, first of all, I'm just going to write 0.4 as 2/5. Okay, so 3 plus negative 2/5 is going to be, of course, 15/5 plus negative 2/5. That's 13/5. That equals to negative b over a. If I multiply these things now, let me switch colors. 3 over 1 times negative 2 over 5. I'm going to get negative 6/5, which of course equals c over a. So negative 6 over 5 is equal to c over a. So it looks like a is 5, so I have 5x squared. B is negative 13, and c is neg 6. There is my equation with roots of 3 and negative 2/5. Okay, we're going to try these things in class, but just you can read this through for yourself. I believe it is in your note packet, and I shall see you soon.